prove that another improper integral, let's make it be 1 over 1 plus x cubed, converges is what it's going to do. What's the interval? I'm going to integrate this from 1 to infinity. Now, I could integrate it from 0 to infinity. It would be okay. But I kind of want to avoid 0 because to prove this converges, I'm not actually going to do the integral. Instead, what I'm going to do is I'm going to compare this integral to another integral. Let's call this function that I'm integrating f of x. The idea is, over this interval, what I'm hoping, so the graph of f of x looks about like this. Over the interval from 1 to infinity, I'm not sure if 1 is at the maximum or not, maybe. I'm hoping this area is finite. Maybe I don't care what it equals. On the other hand, maybe I do care. All I care about at the moment, though, is that it's finite. Does it exist as a finite number? Does this improper integral converge? If I can find some other function above it, whose area I know is finite, then that'll mean this one will have to be finite. And why would I want to do this? Because that integral looks difficult to do by hand. That's why. Maybe the blue curve is a simpler function whose integral I know converges. That other function I'm going to take to be simpler than this f of x function. I'll take it to just be 1 over x cubed. Whose integral from 1 to infinity I know converges. Maybe I can use that somehow. Is it true, though, that f of x is like the red graph and g of x is like the blue graph? Is the graph of f always below the graph of g? Yes, it is. Because I'm dividing by a bigger number in f than I am in g, making the entire fraction for f smaller than it is for g. Let g of x be this function. Note that it does turn out to be important that these are both non-negative functions for all x greater than or equal to 1. That is important to note. Also, we know the improper integral of g of x, because g of x is 1 over x cubed. That corresponds to this situation where p is bigger than 1, p is 3, c is 1, a is 1. We know this converges. We know that. Question? Yes, they should be. Thank you. Sorry, I'm making lots of mistakes here today. We know that integral converges. Therefore, the integral we're interested in also converges. Technically speaking, it's by a theorem. It's by a theorem called the comparison test. So you should quote that theorem at the end. Praise the Lord, we're done.